Hello everyone, welcome to Cosmic Minds. In today's video we will be learning series connection of resistors. Okay, in series connection we all know that electric circuit. Okay, I think you all are aware of electric circuit. Electric circuit is nothing but a closed path created by connecting the wires as well as through a battery. Okay, and we in electric circuit will connect all the electric components, and the path of that particular electric circuit should be closed. Okay, if the path of this particular electric circuit is closed, then it is considered as a closed circuit. If any of the electrical component is not connected properly, if it is any breakdown in between the electrical component, then it is considered as a open circuit. Okay, in electric circuit the path should be totally closed by connecting wires as well as electric component. These are all the electric components. Okay, this we can consider as a resistor, this is the ammeter, this is a cell, or we can consider as a combination of cells, we can consider as a battery. This is the voltmeter, and this is the connecting wires, and this is a switch or key. Okay, these are all what? These are all the electrical components. These are all electrical components. It should be arranged properly so that there should not be any breakdown in between the path, so that is considered as a closed circuit. If any wire, if suppose there is, if there is a breakdown of this here from this wire, so what happened, it is considered as a open circuit. Means there should not be any breakdown in between the path of flow of electrons. Okay, then that is considered a closed circuit. If it is any breakdown, then it is considered, means the current will not flow, means there will not be flow of electrons. If there will not be flow of electrons, what happens, then it is considered as a open circuit. Okay, so what here the say a circuit diagram is given here. So in this circuit diagram we'll consider how the resistors, means when the resistors are connected in series, how the effective resistance will be. Okay, when the resistors, if three resistors, we can consider these three bulbs. Okay, three bulbs you can consider as a three resistor. If these three resistors are connected in series, what will be the effective resistance? Okay, what will be the effective resistance? We can consider two resistors also, we can consider four, as many number of resistors we can place it in a series, and we can calculate the effective resistance, but it should be more than two. Okay, so here the three resistors are being connected. So what is happening, this I can consider resistor, three resistors are connected in series. Series means one after the other, it's gonna means one end of this terminal is connected to the other end, and this other end of this terminal is connected to the other end, and the last end of this particular resistance is connected to the negative terminal. Okay, so now what I am doing, I am placing a battery of 6 volts. Suppose let us consider 6 volts. Okay, soon after placing the 6 volts battery, and if we'll switch on the key, what happens, the electric current starts flowing. Okay, if the electric current starts flowing, the electric current starts from positive terminal and reaches to the negative terminal, high potential to the low potential. Okay, current always flows from high potential to the low potential, whereas electrons flow opposite to this. Means if the current is flowing in this way, positive to negative, the electrons will flow from negative to the positive direction. Okay, so the current is flowing from positive terminal, and here what is happening, see here the current, if I current is flowing, so the current, there is no branches here, there is no branches created here, so the current will start flowing, and it reaches the current resistor 1, and it continues and reaches the resistor 2, resistor 3, and it comes to the negative terminal. Means the flow of current is in a single path, in single direction, means in single, it is starting from positive and reaching the negative terminal. There is no branches, there is no division of the current. Okay, how we can know that there is no division of current? So we'll measure with the help of the ammeter. Okay, suppose instead of placing the ammeter here, I'll place the ammeter in between these terminals. Then I'll come to know what's the current flowing. Ammeter gives the reading of the current flowing in this resistance, isn't it? The current flowing in this resistance, it will be given in the ammeter, and the current flowing in this resistance, I'll arrange another ammeter here. Again I'll arrange the ammeter, one more ammeter here. Okay, by arranging this, what it will be easy for us to know the current in each resistor. Okay, and in order to know the potential difference, what I'll do, I'll arrange the voltmeter between the ends of these two terminals. Okay, now the 6 volts I'm applying, 6 volts we are using. So what happens here, the current starts flowing here. So we can observe, what we can observe is the current flowing in ammeter 1 and ammeter 2 and ammeter 3 is same. The current flowing in this will be same current will be flowing. Suppose if suppose 6 voltage we are saying, suppose 2 amperes current is flowing, means the current flowing in resistor, current flowing in bulb resistor 1 will be 2 amps will be flowing, means the current the flowing of the electrons will be same in resistor 1, resistor 2, resistor 3. Okay, but the voltage, what is happening here, the voltage is not same here. So what is happening here, if we connect the voltage here V1, V2 and V3, here we can, what we can observe in voltmeter is the voltage is differing here. Okay, suppose 6 voltage is there, suppose the voltage here may be 2 volts, it may take 2 volts, or 1 volt it may take 1 volt, again 6 na 2 3 4 5, okay, one more 3 volts here, means what is it, depending upon the resistance, means depending upon the resistance the voltage will differ. Suppose, but the total voltage will be distributed here. The total voltage may not distributed equally, depending upon the resistance it may vary, but the total voltage will be taken by 3 resistors. Okay, it means we can't tell that 6 volts means 2 volts. Okay, depending upon the usage, the resistor may take 2 volts, or some resistor may take 1 volt, this may take 1 volt, or this may take 2 volt. Depending upon the usage of this resistor, the voltage may differ, but the 6 volts will be distributed equally. 6 volts will be distributed in between these 3 resistors. Okay, in between these 3 resistors, depending upon the usage, 2 1 1 or 3 1 1 1, but 6 will be distributed in between these 3 resistors. Okay, so what is here in a series connection, what is happening here, current will be the same, here, current will be same, but the potential difference or voltage will be distributed. Okay, current is being same in series connection, means the current passing in resistor 1, resistor 2, resistor 3 will be same. How we came to know that same? We are placing here ammeter. In this ammeter, what we can see here, what we can observe here is the current flowing in here in this resistance ammeter 3, in 3 ammeters the current flowing, it's showing as 2 amps only. So means the current flowing in these 3 resistors is same, means whenever we'll arrange the connection in series connection, the current passage in all the resistors will be same, current will be flowing, but the potential difference will be different depending upon the resistor. Suppose if you are using here TV, fridge and suppose some toaster or a heater or something, means depending upon the resistors, voltage may differ. It may take 120 volts, it may take 220 volts, or it may take 240 volts. Okay, depending upon the resistance it may vary, means current will be same here, but the potential difference will be different. Okay, potential difference will be distributed. Suppose what was the same, suppose here I am considering here, suppose the volt potential difference across this terminal, that is in the battery, we are considering as a V, means it is V. So we are considering 3 resistors, means 3 resistors means what we can tell, V1 plus V2 V3, because voltage V is distributed between 3 resistors. Voltage V is distributed between 3 resistors. So V1, V2, V3. The sum of the potential difference of the bulbs is equal to the potential difference across the combination of the resistors. Means the potential difference, the sum of this potential difference, means sum of the sum of the potential difference of the bulbs, V1 bulb, V2 bulb, V3 bulb, means potential difference across V1, potential difference across V2, potential difference across V3 is equal to 6. Suppose 6 volts means 1 volt, 2 volts plus 3 volts, means sum of the potential difference is equal to that of the sum of the potential difference of the bulbs, means individual differences is equal to the potential difference. Okay, means if we add this 3 potential difference, it should be equal to the potential difference what we are giving to the circuit. Okay, so this is the, so here measure the values, what we have seen, the current is same here but the potential difference is distributed. Suppose here we are seeing here, suppose we are considering here the current. See the current, it is flowing in one path. Okay, one singular path. Okay, unidirection current means it is flowing in one direction, means the direction of the current is unidirection current. But here what is happening, here the potential difference is being distributed in three resistors. Here suppose the total potential difference created between this terminal, this positive terminal, and it is going to the negative terminal is V, and the V is being distributed in between R1, R2 and R3, means V1, V2 and V3. Okay, V1, V2, V3. Now according to Ohm's law, we know, what we know, that V is equal to, according to Ohm's law, V is equal to IR. According to Ohm's law, V is equal to IR. See here it is given, in series connection of resistor there is only one path for the flow of electrons in the circuit. Means see here the current, the direction of the current is single path, means unidirection current. It is passing from the through the resistor and it is going to the other terminal, means unidirection, single path, one path. Okay, according to Ohm's law, V is equal to IR, means potential difference here, potential difference across R1 here, potential difference across R1. What is the potential difference across R1? How can we write potential difference? V1, here V1, Ohm's law, V is equal to IR. V is equal to IR is potential difference. Suppose I want to know the potential difference of this particular resistors, means for our resistor 1. Okay, resistor, I want to know the potential difference of potential difference across resistor 1. So we can write V1 is equal to IR1. In the same way V2 and V3. V1, V2 and V3. Suppose I want to know the combination of all these resistors. Combination of all these resistors is nothing but the effective resistance. Effective resistance is nothing but what? Combination of resistors. Combination of resistors is nothing but the effective resistance. Okay, combination of resistors is nothing but the effective resistance. So what do you mean by effective resistance? The combination of resistors is nothing but the effective resistance. Means what it means is, what actually it means is, effective resistance means the current flowing, I1, I2 and I3 in these three resistors is equal to the effective resistance. Means the current drawn by a resistor is equal to the current drawn by the combination of resistors. Then the resistors is called equivalent resistance. Means the current which has been drawn in resistors R1, R2 and R3 is equal to that of the I. To that of the I, means suppose the current here is I, which is equal to the current which is being given in the circuit. Okay, so we have V is equal to I R effective resistance. R effective resistance, instead of R1, R2, R3, instead of R1, R2, R3, I am writing R effective resistance. Instead of, suppose R effective resistance is equal to R1 plus R2 plus R3. Okay, means sum of individual resistance is equal to the resistance, means total resistance in this. Suppose here 1 ohm, this is 2 ohms, this is 3 ohms, means what is the total resistance here? 6 ohms. 1 plus 2, 3, 3 plus 3, 6, means 6, means sum of the resistance, sum of the individual resistance is equal to the what? Is equal to the effective resistance. Okay, is equal to the effective resistance. In the same way, so we have V is equal to what? V is equal to IRQ, means I R effective resistance. I R effective resistance. This is what? Total potential difference which we are giving. Okay, suppose if I will take the potential difference across resistance R1, Potential difference across resistance R1 is V1 is equal to IR1, V2 is equal to IR2. For second bulb, this is the third bulb. Okay, first bulb, second bulb, third bulb, potential difference. So substituting these values of V1, V2, V3 and V in equation 1. Which is the equation 1 here? We got the equation 1 here. We can substitute in this. Okay, we are here. V1 is equal to IR1, IR2 and IR3. Okay, substitute here. Substitute, if you will get V is equal to, means this is the V, this is the V1, this is the V2, this is the V3. Okay, V1, V2, V3. Okay, in here equation 1, in equation 1 we have to substitute it here. Okay, V is equal to V1, V2, V3. V1, V2 and V3. So V means what? IR1, effective resistance. Okay, R1, resistance of potential difference across resistance 1, 2 and 3. So R equivalent resistance is equal to R1, R2 and R3. Means from this we can conclude that the sum of the individual resistance, means sum of this individual resistance is equal to that of the effective resistance. Means suppose if you are taking 1 ohm, 2 ohm, 3 ohm, it should be equal to the 6 ohms. Okay, so what happens here is one application question is, what happens when one of the resistor in series breaks down? What happens if one of the series breaks down? Suppose here suppose what happened here, there is a, this is a electric circuit. Okay, means electrical connection diagram. So what happens here, if here suppose the current is flowing from this terminal and it has reached till here terminal. Due to the breakdown of this circuit or in wiring, it has been breakdown. So will the current flow in second resistance? Will the current flow in second bulb? It will not flow, as there is a breakdown and the path of this electron has been disturbed here. Means there is no flow of current. It has become an open circuit. That's the reason why the circuit, it should be closed circuit. Now if there is a breakdown here in the wirings, what happens? It will become the open circuit. The current will not be able to move in forward direction, so it will be a breakdown here. So the current will not be able to move. Means if there is a breakdown in one terminal, means if there is a breakdown, if the one appliances is not working, then the other appliances will stop working, because there will not be a flow of current, there will not be flow of electron. When one of the resistance in series breakdown, what happened? The circuit becomes open circuit and the flow of electrons cannot take place. This is the reason why household electrical appliances are not connected in a series. Then one more thing what we can remember here is, always the R equivalent resistance will be more than that of the individual resistance. Suppose we are taking here 1 ohm, 2 ohms and 3 ohms. 1 ohms, 2 ohms and 3 ohms. The individual resistance is 1 ohm, 2 ohm and 3 ohms. But the effective resistance which we got is more than the sum of the individual resistance. 6 ohms we got, means this is more than that of the individual resistance. Always in series connection, the resistance will be more. Always in series connection, the resistance will be more. If the resistance will be more, what happens? The flow of current will be less. So mostly we prefer parallel connection in housing, because in parallel connection resistance will be less. If the resistance will be less, current will flow more. Means the obstruction of current will not be much. But in series connection, what is happening here? The resistance is more. If the, see 1, 2, 3 ohms means 6 ohms. The resistance is more. If the resistance is more, current will be less. So in house wirings, what happens? Usually we won't prefer series connection. We prefer parallel connection. So that the resistance will be less in parallel connection and the current will be more. Okay, that's it in series connection.